This time, we're learning lesson 2.5, Indices. Let's start. Revisiting index notation. You already know how to write powers of 2 and 3 using indices. 2 times 2 is 2 squared, 2 times 2 times 2 is 2 cubed, and y times y is y squared, y times y is y cubed. When you write a number using indices or powers, you have written it in index notation. Any number can be used as an index, including 0, negative integers, and fractions. The index tells you how many times the base has been multiplied by itself. So 3 times 3 times 3 times 3 equals 3 to the power of 4. 3 is the base and 4 is the index. 8 times 8 times 8 times 8 times 8 equals 8 to the power of 5. 8 is the base and 5 is the index. Work example 11. Write each expression using index notation. 2 times 2 times 2 times 2 times 2 times 2. X times X times X times X. X times X times X times Y times Y times Y times Y. So you count how many times 2 is multiplied by itself to give you the index. So there's 1, 2, 3, 4, 5, 6 2's. And you do the same, but instead of counting 2's, you count X's. So there are 1, 2, 3, and 4 X's. For C, you count how many times X is multiplied by itself to get the index of X, which is 3. Then work at the index of Y in the same way, which is 4. Then put the variables together, and you get X to the power of 3, Y to the power of 4. Work example 12. Use your calculator to evaluate 2 to the power of 5, 2 to the power of 8, 10 to the power of 6, and 7 to the power of 4. So, for each of these calculations, you enter the base in the calculator, then you use the index button, and then you type in the index. So first, you type in the base. Next, you type in the index button. Finally, you type in the index. And then you type in the equal sign. So 2 to the power of 5 equals 32. 2 to the power of 8 equals 256. 10 to the power of 6 equals 1 million. And 7 to the power of 4 equals 2,401. Index notation and products of prime factors. Index notation is very useful when you have to express a number as a product of its prime factors, because it allows you to write the factors in a short form. Work example 13. Express these numbers as products of their prime factors in index form. The numbers are 219,683. So you could use the factor tree or the division methods for finding the prime factors. So 200 is 2 times 2 times 2 times 5 times 5, or 2 cubed times 5 squared. 19,683 is 3 times 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 3, or 3 to the power of 9. Exercise 2.7. Question 1. Write each expression using index notation. 2 times 2 times 2 times 2 times 2. 3 times 3 times 3 times 3. 7 times 7. 11 times 11 times 11. 10 times 10 times 10 times 10. 8 times 8 times 8 times 8 times 8. 8 times 8 times 8 times 8. X times X times X times X times X. Y times Y times Y times Y times Y times Y. A times A times A times B times B. X times Y times Y times Y times Y. P times P times P times Q times Q. X times X times X times X times Y times Y times Y. X times Y times X times Y times Y times X times Y. A times B times A times B times A times B times C. Question number 2. Evaluate. 10 to the power of 4, 7 to the power of 3, 6 to the power of 7, 4 to the power of 9, 10 to the power of 5, 1 to the power of 12, 2 to the power of 10, 9 to the power of 4, 2 to the power of 6, 2 cubed times 3 to the power of 4, 5 squared times 3 to the power of 8, 4 to the power of 9, 4 to the power of 5 times 2 to the power of 6, 2 to the power of 6 times 3 to the power of 4, 2 to the power of 8 times 3 squared, and 5 cubed times 3 to the power of 5. Question 3. Express the following as products of prime factors in index notation. 64, 243, 400, 1,600, 16,384, 20,736, 59,049, 390,625. Question 4. Write several square numbers as products of prime factors using index notation. What is true about the index needed for each prime? The laws of indices. The laws of indices are very important in algebra because they give you quick ways of simplifying expressions. You will use these laws over and over again as you learn more and more algebra. So it is important that you understand them and that you can apply them in different situations. Multiply the same base number with different indices. You get these two multiplications. 3 squared times 3 to the power of 4, x cubed times x to the power of 4. In the first multiplication, 3 is the base number, and in the second, x is the base number. You already know that you can simplify these by expanding them like this. 3 times 3 times 3 times 3 times 3 times 3, which is 3 to the power of 6. And x times x times x times x times x times x times x, or x to the power of 7. In other words, 3 squared times 3 to the power of 4 equals 3 to the power of 2 plus 4. X cubed times x to the power of 4 equals x to the power of 3 plus 4. This gives you the law of indices for multiplication. When you multiply index expressions with the same base, you can add the indices. X to the power of n times x to the power of n equals x to the power of m plus n. Work example 14. Simplify 4 cubed times 4 to the power of 6. X squared times x cubed. 2x squared y times 3xy to the power of 4. So for A, you add the indices, which is 4 to the power of 9. For B, you also add the indices, which is x to the power of 5. Then for C, you multiply the numbers first, and then add the indices of the like variables. Dividing the same base number with different indices. Look at these two divisions. 3 to the power of 4 divided by 3 to the power of 2, and 6 to the power of 6 divided by 6 squared. You already know you can simplify these by writing them in expanded form and canceling like this. You cancel out 2 pairs of 3's. And here you also cancel out 2 pairs, but of x. So whatever that's left is your answer. 3 times 3. 3 squared, or x times x times x times x, or x to the power of 4. In other words, 3 to the power of 4 divided by 3 to the power of 2 equals 3 to the power of 4 minus 2. And x to the power of 6 divided by x squared equals x to the power of 6 minus 2. This gives you the law of indices for division. When you divide index expressions with the same base, you can subtract the indices. X to the power of m divided by x to the power of n equals x to the power of m minus n. Work example 15. Simplify. X to the power of 6 over x to the power of 2. 6x to the power of 5 over 3x to the power of 2. 10x cubed 3y squared over 5xy. So for the first expression, you subtract the indices. In the second one, you divide or cancel the coefficients, and then subtract the indices. And the same for the last expression. The power 0. You should remember that any value divided by itself gives 1. So 3 divided by 3 equals 1, and x divided by x equals 1. And x4 to the power of 4 over x to the power of 4 equals 1. If we use the law of indices for division, we can see that x to the power of 4 over x to the power of 4 equals x to the power of 4 minus 4 equals x to the power of 0. This gives us the law of indices for the power 0. Raising a power. Look at these two examples. X cubed squared equals x to the power of 3 times x to the power of 3, which is x to the power of 3 plus 3 equals x to the power of 6. And 2x to the power of 3 to the power of 4 equals 2x to the power of 3 times 2x to the power of 3 times 2x to the power of 3 times 2x to the power of 3 equals 2 to the power of 4 times x to the power of 3 times 3 plus 3 plus 3, which is 16x to the power of 12. If we write the examples in expanded form, we can see that x cubed squared equals x to the power of 6, and 2x cubed to the power of 4 equals 16x to the power of 12. This gives us the law of indices for raising a power to another power. When you have to raise a power to another power, you multiply the indices. X to the power of m to the power of n equals x to the power of mn. Work example 16. Simplify. X cubed to the power of 6. 3x to the power of 4, y to the power of y cubed squared. x cubed to the power of 4 divided by x to the power of 6 squared. Step 1. Multiply the indices. For the next expression, you square each of the terms to remove the brackets and multiply the indices after. For equation 3, you expand the brackets first by multiplying the indices, and then divide by subtracting the indices. Exercise 2.8. Question 1. Simplify. 3 squared times 3 to the power of 6. 4 squared times 4 to the power of 9. 8 squared times 8 to the power of 0. X to the power of 9 times x to the power of 4. Y squared times y to the power of 7. Y cubed times y to the power of 4. Y times y to the power of 5. X times x to the power of 4. 3x to the power of 4 times 2x to the power of 3. 3y squared times 3y to the power of 4. 2x times x cubed. 3x cubed times 2x to the power of 4. 5x cubed times 3. 8x to the power of 4 times x cubed. 4x to the power of 6 times 2x. X cubed times 4x to the power of 5. Question 2. Simplify. X to the power of 6 divided by x to the power of 4. X to the power of 12 divided by x cubed. Y to the power of 4 divided by y cubed. X cubed divided by x. X to the power of 5 divided by x. X to the power of 6 divided by x to the power of 4. 6x to the power of 5 divided by 2x cubed. 9x to the power of 7 divided by 3x to the power of 4. 12y squared divided by 3y. 3x to the power of 4 divided by 6x cubed. 15x cubed divided by 5x cubed. 9x to the power of 4 divided by 3x cubed. 3x cubed divided by 9x to the power of 4. 16x squared y squared divided by 4xy. 12xy squared divided by 12xy squared. Question 3. Simplify. X squared squared. X squared cubed. X squared to the power of 6. Y cubed squared. 2x squared 5 to the power of 5. 3x squared y squared squared. X to the power of 4 to the power of 0. 5x squared to the power 5x squared cubed. X squared y squared cubed. X squared y to the power of 4 to the power of 5. X y to the power of 4 cubed. 4xy squared squared. 3x squared to the power of 4. Xy to the power of 6 to the power of 4. X squared over y to the power of 0. Question 4. Choose the appropriate laws of indices to simplify these expressions. 2x squared times 3x cubed times 2x. 4 times 2x times 3x cubed y. Times 3x squared y. 4x times x squared. X squared divided by 4x squared. 11x to the power of 3 times 4a squared b squared. 4x x squared plus 7. X squared 4x minus x to the power of 3. X to the power of 8 divided by x cubed squared. 7x squared y squared divided by x cubed y squared. 4x squared times 3x to the power of 4 divided by 6x to the power of 4. X to to the power of 4 divided by y squared cubed. X to the power of 8 times xy squared to the power of 4 over 2x squared over 4. X squared to the power of 0. 4x squared is 2x cubed divided by 2x to the power of 0. 4x squared y cubed squared divided by 2xy cubed. Negative indices. At the beginning of this unit, you read that negative numbers can also be used as indices. But what does it mean if an index is negative? Look at the two methods for working out x cubed divided by x to the power of 5 below. Using expanded notation, or using the laws of indices for division. This shows that 1 over x squared equals x to the power of negative 2. This gives you a rule for working with negative indices. X to the power of negative m equals 1 over x to the power of m when x is not equal to 0. When an expression contains negative indices, you apply the same laws for other indices to simplify it. Work to example 17. Find the value of 4 to the power of negative 2 and 5 to the power of negative 1. So here are the answers. Question 2. Write these with a positive index. So here are the answers again. Simplify. Give your answers with positive indices. 4x squared over 2x to the power of 4. 2x to the power of negative 2 over 3x to the power of negative 4. 3y squared to the power of negative 3. So here are the answers, the bottom row, not the top ones, but the bottommost rows. Exercise 2.9. Question 1. Evaluate 4 to the power of negative 1, 3 to the power of negative 1, 8 to the power of negative 1, 5 to the power of negative 3, 6 to the power of negative 4, and 2 to the power of negative 5. Question 2. State whether the following are true or false. 4 to the power of negative 2 equals 1 over 16. 8 to the power of negative 2 equals 1/16. 6 to the power of negative 3 equals 1 divided by 3x. 2x to the power of negative 2 equals 1 over x. Question 3. Write each expression so that it has only positive indices. X to the power of negative 2, y to the power of negative 3, xy to the power of negative 2, 2x to the power of negative 2, 12x to the power of negative 3, 7y to the power of negative 3, 8xy to the power of negative 3, 12x to the power of negative 3, y to the power of negative 4. Question 4. Simplify. Write your answer using only positive indices. X to the power of negative 3 times x to the power of 4. To the power of negative 3 times 3x to the power of negative 3. 4x cubed divided by 12x to the power of 7. X to the power of negative 7 divided by x to the power of 4. 2x squared to the power of negative 3. X to the power of negative 2 cubed. X to the power of negative 3 divided by x to the power of negative 4. and x to the power of negative 2 divided by x cubed. Summary of index laws. When multiplying terms, add the indices. When dividing, subtract the indices. When finding the power of a power, multiply the indices. Any value to the power 0 is equal to 1 when x is not equal to 0. Fractional indices. The laws of indices also apply when the index is a fraction. Look at these examples carefully to see what fractional indices mean in algebra. X to the power of a half times x to the power of a half. So use the law of indices and add the powers. In order to understand what x to the power of a half means, ask yourself, what number multiplied by itself will give x? X, the square root of x times the square root of x equals x. So, x to the power of a half equals the square root of x. Y to the power of a third times y to the power of a third times y to the power of a third equals y. What number multiplied by itself and then by itself again will give y? So the cube root of y times itself, then times itself again will give y. So y to the power of a third equals the cube root of 9, y. This shows that any root of a number can be written using fractional indices. So 1 to the power 1, so x to the power of 1 over m equals the m root of x. Rewrite using root signs. Y to the power of a half, x to the power of a fifth, x to the power of 1 over y. And write these in index notation. The square root of 90, the cube root of 64, the fourth root of x, the fifth root of x minus 2. Dealing with non-unit fractions. Sometimes you may have to work with indices that are non-unit fractions. For example, x to the power of 2/3 or y to the power of 3/4. To find a rule for working with these, you have to think back to the law of indices for raising a power to another power. Look at these examples carefully to see how this works. You already know that a unit fraction gives a root. So we can rewrite these expressions using root signs like this. X to the power of 1 over 3 squared equals the cube root of x squared, and y to the power of a fourth cubed equals the fourth root of y cubed. So x to the power of 2/3. That's a little small. That's a little better. So x to the power of 2/3 equals the cube root of x squared. And y to the power of 3 over 4 equals the fourth root of y cubed. In general terms, x to the power of m over n equals x to the power of m times 1 over n equals x to the power of 1 over n to the power of m equals the nth root of x to the power of m. Work example 19. Work out the value of 27 to the power of 2/3, 25 to the power of 1.5. 27 to the power of 2/3 equals the cube root of 27 squared, which is 3 squared, which is 9. 25 to the power of 1.5 equals 25 to the power of 3 over 2, which is the square root of 25 cubed, or 5 cubed, which is 125. Sometimes you are asked to find the value of the power that produces a given result. You have already learned that another word for a power is exponent. The equation that requires you to find the exponent is called an exponential equation. Work example 20. If 2 to the power of x equals 128, find the value of x. Remember, this means 2 equals the x root of 128. Find the value of x by trial and improvement. So 2 to the power of 7 equals 128, and x equals 7. Exercise 2.10. Evaluate 8 to the power of 1/3. 32 to the power of 1/5. 8 to the power of 4/3. 216 to the power of 2/3. 256 to the power of 0.75. Question 2. Simplify. X to the power of 1/3 times x to the power of 1/3. X to the power of 1/2 times x to the power of 2/3. X to the power of 4 over x to the power of 10 to the power of 1/2. X to the power of 6 over y squared to the power of 1/2. X to the power of 6 over 7 over x to the power of 2/7. 7 over 8 x to the power of 1/2 divided by 1/2 x to the power of -3 over 2. 2x to the power of 2/3 over x to the power of 8/3. 9x to the power of 1/3 divided by 12x to the power of 4/3. 1/2 x to the power of 1/2 divided by 2x squared. Negative 1/2 x to the power of 3 to the 3/4. Divided by negative 2x to the power of -1/4. 3/4 x to the power of 1/2 divided by 1/2 of x to the power of -1/4. -1/4 x to the power of 3/4 divided by -2 x to the power of -1/4. Question 3. Find the value of x in each of these equations. 2 to the power of x equals 64. 196 to the power of x equals 14. X to the power of 1/5 equals 7. X minus 1 to the power of 3/4 equals 64. 3 to the power of x equals 81. 4 to the power of x equals 256. 2 to the power of -x equals 1 over 64. 3 to the power of x minus 1 equals 81. 9 to the power of -x equals 1 over 81. 3 to the power of -x equals 81. 64 to the power of x equals 2. 16 to the power of x equals 8. And 4 to the power of -x equals 1 over 64. So, summary. Do you know the following? Algebra has special conventions or rules that allow us to write mathematical information in short ways. Letters in algebra are called variables. The number before a letter is called a coefficient, and numbers on their own are called constants. A group of numbers and variables is called a term. Terms are separated by plus and minus signs, but not by times or divide signs. Like terms have exactly the same combination of variables and powers. You can add and subtract like terms. You can multiply and divide like and unlike terms. The order of operation rules for numbers or BODMAS apply in algebra as well. Removing brackets or multiplying out is called expanding the expression. Collecting like terms is called simplifying the expression. Powers are also called indices. The index tells you how many times a number or a variable is multiplied by itself. Indices only apply to the number or variable immediately before them. The laws of indices are a set of rules for simplifying expressions with indices. These laws apply to positive, negative, zero, and fractional indices. Are you able to use letters to represent numbers, write expressions to represent mathematical information, substitute letters for numbers to find the value of an expression, add and subtract like terms to simplify expressions, multiply and divide to simplify expressions, expand expressions by removing brackets and getting rid of outer grouping symbols, use and make sense of positive, negative, and zero indices, apply the laws of indices to simplify expressions, work with fractional indices, and solve exponential equations using fractional indices. So that's the end of this lesson. Thank you and goodbye.